Welcome back to my channel, the Data Odyssey. Till our last video, we had discussed about the metadata files. Now in this video, as you can see on the screen, we have metadata tables. Now, literally, if you try to find out a relation between them, they are both similar, right? But in what manner? Basically, this metadata table consists of those metadata files. They consist the information about them. Okay. Now, why are they useful in the production environment? So see, let us try to find out like when can these tables be useful, and then we'll try to dive into first four of the metadata tables. As you can see on the screen, these four, and maybe in the next video we'll look into these 5 metadata tables. In total there are 9 metadata tables that we have for Iceberg. Okay, so in this world we have two kinds of people, right? One of those who are very proactive, and then those who are very reactive are the people who actually react according to the situations, and proactive are those people who try to react prior to any situation. Okay, so in the world of data engineering or big data, what happens is when are these approaches useful? So the reactive approach is useful. For example, you prior to going to the production environment or while development even, okay, you had not thought about the optimization process related to this metadata file. See, whenever we create a table, we have the backend Parquet files, right, storing data for them. Now these files have their own storage. Okay, when we read the table, when we query upon the table, select star from this particular table or select the certain number of columns from this particular table, basically all these files are scanned. Or suppose you perform a merge statement, then again all these files are scanned with respect to the number of basically the scanning also takes place according to the partitioning that we have made for the particular table. Okay, now that's a different concept, maybe we'll discuss in some other class. But yeah, so just remember that when we scan on a particular table, it all depends upon the partition. So even though you just query upon maybe a particular date and you have not partitioned upon date, you have partitioned upon month, then also the entire date would be scanned. But then, as we have learned that Iceberg comes as a savior, by default it performs dynamic partitioning. So if you perform by, you know, maybe month, or maybe by date, it will perform partitioning by month. So from, if you perform partitioning upon the date, it will perform partitioning on the month, on the year by itself. Okay, so yeah, again that's a different story, not it's not in relevance to this particular video. Okay, so what we have learned that they have a particular storage related to it. So react in a reactive approach, what you basically do, okay, you have gone to the production environment, and then one day suddenly your client comes up or the stakeholders comes up and says that, hey brother, my cost is increasing, what should I do? You need to reduce the cost. We had started this engineering project not only with the purpose of, you know, the entire organization benefiting from the single place of, or the single house of data, data inputs, or like multiple sources of data being put at one place. We are not only made this project for this purpose, but also at the same time we had also a certain thing in mind to reduce the cost. So previously mostly the purpose of data engineering projects is data are present in silos. Now they want to bring all the data at one place. That's the simple funda of any data engineering project. Now if you are bringing data at one place and then your cost is increasing, then it's alarming, right? So in reactive approach, what you do, basically you try to reduce down the cost. You try to check, like, see, there are multiple files that we have in our backend. Can we some way compact these files? Can we some way merge these files together? Can we perform a better partitioning on the table, right? That's a reactive approach after everything has gone. Then there's a proactive approach again. What you do, you just take a subset of the data, and that's why there are multiple environments, right? Dev, QA, prod, in any project, not only in engineering perspective, but in any project, right? I'm in data engineering perspective. So in QA, you take a subset of the data, you perform analysis upon the data. So what subset of the on which kind of subset? Basically the production subset, right? So you take a subset of the production data, you perform analysis upon it, you understand the cluster required for the entire process, for the entire logic, you find the cost involved with it, you find out ways of optimization. So going forward, when data volume increases, your cost of storage doesn't increase, maybe it kind of gets optimized, you write the code for it, right? So these kinds of analysis, you find a trend amongst the data, you find the try to find the data pattern. From pattern, I do not mean like the data science pattern, right? Not a trend with respect to business, a trend with respect to the data. Suppose you want to find out that generally when does null value comes up, right? Or generally when a particular data gets deleted, we need to perform a hard delete from the final table according to the instructions by the client. So these are the multiple kinds of things that we do prior to going to the production. So these are the two approaches that any data engineer or any individual follows within the project. So one is a proactive approach, one is a reactive approach. See, it's always not possible to go proactive. So certain times people do go reactive, and it's necessary. Suppose you have performed the entire project, you do not have the time, and then the client will just see first deliver us the output, and then going forward we'll sit and understand about the optimization process, right? So there are the two approaches, both of them are not wrong. End of the day, we need to reduce down the cost. Okay, so that was kind of in terms of Hindi we say gyan. Okay, that was kind of gyan that was given by me, but it's important to know these the different kinds of approaches that we do follow in real life as data engineers. Okay, now let us start with the metadata tables. See on the table what you see. So for all of these optimization processes, for all of these reactive or proactive approaches, we do require these metadata files, and a greater amount of information for those metadata files are present in these metadata tables. So let us just understand about the metadata tables. It's required in the production environments. It's very useful. Okay, so what are the different kinds of metadata tables that we have? One is a history metadata table, then there's a snapshot metadata table, then we have the files metadata table, we have the manifests metadata table, we have the partitions metadata table, we have the all data files, all manifest files, refs metadata table, entries metadata table. In this video, we'll try to understand these four metadata tables. Okay. Going forward in the next video, we'll understand about these 5 metadata tables. We'll complete it, and then there's a surprise at the end of this video which I'll tell. Okay, but first let us go through these 4 metadata tables. Okay, so as we know, in the last video we had gone through all the metadata files till our last video basically. Okay, so on the screen what you can see, we have the history metadata table. Now what does it contain? Let us try to understand it. Okay, so on the screen you can see it's written the history metadata table is essential for tracking the evolution of table. Now what do I mean by the evolution of table? Basically the evolution of table means the evolution of data over time within the table, right? So you have multiple versions of a table, version 1, version 2, version 3, version 4, multiple versions. That is the evolution of a table. When you first, we have seen in our last video, right? We create a table, there's version 1. You insert data in the table, there's version 2. Again, suppose you alter the table, then there's version 3. And we had also seen, right, the multiple schema versions were also getting created. So schema ID 1 was with respect to the first schema. Now suppose if you alter the table, schema ID does get changed. It does not get changed when you insert data into the table, correct? So yeah, that's the evolution of the table. Okay, it's with respect to only addition of data or updation of data, but maybe you alter the table, then also it does track it. Now when does the first evolution of table comes into consideration. Okay, see, all these metadata tables starts tracking your data once you perform what. Okay, so let me just show you my last you know, okay, last video's notebook. We'll see what we had last performed on the table, and then maybe it will be easier for you to understand the evolution of the table. Okay, so as you can see on the screen, we have created the table, correct? And then if you go down, you see, when you created the table, there are two files only formed. One is metadata.v1.metadata.json, and then there is version in .text. No other metadata files were formed, right? Now let us go down. You inserted data into the table, and then what happened is basically these files started getting formed. The one new metadata.json file got formed, vd.metadata.json, right? Then we had also discussed that manifest files got formed, right? And since manifest files have got formed, then manifest list will also get formed. We had discussed that snap dash means the manifest list. And then we had the version in the text, and when we had to read it, it had version 2. That means we had inserted data in the table, right? So if I just read this data, let us see, like, are we sure these insertion have taken place? Because only one snapshot is getting shown over there. So let's see that. It's running, and one second. So it's running. So like, let it run. So till then, just, you must be getting it right. Actually, we have inserted data in the table, but it's showing only one snapshot. Why is it showing that? So basically what is happening, that when you insert data into the table, it's showing only one value. Okay, while creating, it has not stored the snapshot for it. Okay, let's just see it. Why is it taking time so much? So let it run till then. Let us see over here. Let us see, go through the columns for it. So what does made current at mean? Made current at mean that when was the particular snapshot created? Okay, when was the particular change done to the table? That's the timestamp basically. Then obviously you have this snapshot ID. You have your particular snapshot ID, right? And is the current ancestor. What does it mean? So you have two columns over here, parent ID and then the current ancestor. Parent ID basically mean you have a particular snapshot ID, but when you evolve through the tables, so you have snapshot ID, you have one, okay? Now you make certain changes to the table, the snapshot ID 2 does get formed. That's the evolution of a particular table, right? But over here we can see that the parent ID field has got null value, right? Let us just see this. Yeah, you see, we had inserted data into the table, and that's why this manifest uh, list had got formed, correct? Now uh, let us go through this. See, now manifest file starts storing the data when it's the first uh, insertion into the table, when manifest file starts storing the data, correct? So that's what you can see, that these snapshot IDs are getting stored when the first insertion into the table takes place, rather not when the creation of the table has taken place, because till then these files, manifest file, manifest list, had not got formed, correct? So this is the first insertion into the table when this manifest files and manifest list got formed, which have information about the snapshot ID, and that means this snapshot. So this snapshot actually is the first snapshot. So when first insertion takes place, the first snapshot gets formed. Just know it. Okay, now suppose if we insert values into the table, okay, we had inserted these three values, correct? Now let us see, maybe over here we insert certain more values into the table. just remove it. One value, let us insert it. Insert 4. Let us see what happens. Okay, and then maybe enterprise. Okay, not enterprise over here, maybe enterprise over here. Just insert values into the table. Okay, it won't take much time. Cannot write to the okay. Why is it happening like this? Data ODC cluster. Incompatible data. Why it's incompatible data? Uh, maybe. Okay. Let us just go through it again. Let us try to insert it. Incompatible data by 4, 5, 6, 1, 1. Now, oh, okay. SQL, technology 1, sales 1, sales 1. Incompatible data. Okay. Not default, but a diagnosis error. Let's see what is the issue with it basically. Manager ID. Do I have a manager ID? When did it get? Okay. So what had happened basically is that at the end of the day, end of this, I had altered the table. Okay, if you see over here, so right, is it there? Yeah, see, I'd altered the table. I'd added the column manager ID column, right? So that's why it's showing incorrect data. Maybe if I go down, and what I do basically is I place it over here. At the end of the day, I need to add the manager ID, and I just add for enterprise technology, and maybe 7. Okay, let's see, is it getting inserted? Yeah, it's getting inserted, right? So it's a live example of how you basically debug. Basically, I didn't remember that manager ID had inserted in this table, or like I'd created an extra column. Now let us see that what has happened. Okay, I inserted value into the table. Now is there multiple snapshots which getting formed? Let us see at that. Okay, you see a new snapshot got formed. Okay, now what has happened basically, this was the first snapshot. So when you insert values into the table, when you make changes to the table, then only these snapshots are getting formed. Okay, so when you created the table, when I altered the table, no snapshot were formed. So what happens is basically this alteration or creation of the table, these kind of informations are not stored within the manifest files or the manifest list, because they contain information with respect to the data files only. Okay, so just remember this point, right? So first snapshot ID. So when you inserted first 3 values into the table, 1 to 3 insertion, IDs 1 to 3, we had done insertion, right? If you see over here, these 3 values, let me just delete this one, right? So these 3 values, when you inserted them into the table, what had happened? The first snapshot ID got formed, and if you compare it, 54374 46 at the end, right? So when I look at over here, 54374 and 46 at the end, correct? So you inserted first value into the table, then I'd alter the table I'd shown you, but the snapshot ID for it was not getting stored. Okay, but when I again inserted value into the table, again a new snapshot ID got formed. So this is the new snapshot ID. Now if you look at over here, parent ID. Okay, what is it? It's basically this value. if you look over here, this one is the value, this value is similar to this one. That means this was the first snapshot. Now when a new data got inserted, a new snapshot ID got formed, but on the top of which data files the data got inserted? The older data files. Then the older snapshot ID, on the top of older snapshot ID, the newer snapshot ID was formed, and the older snapshot ID is obviously the parent. So basically the parent child relationship, right? So this is the new snapshot ID and it's its parent, right? And is it the current ancestor? So is it part of the evolution of the table? Right, it's part of the evolution. By any chance, see what happens in a real life production environment. After certain number of days, the older snapshot gets deleted. We basically try to set the number of days after which the files, after which the snapshot should get deleted and the files with respect to it. And that's what is happening over here. So maybe if we had set up that this snapshot ID gets deleted, okay, what would have happened? This is current ancestor would have been false. Okay, so basically a part of the parent child relationship. So maybe your great grandfather has died, so he is not the current ancestor. He's dead, right? I'm sorry for using the word dead. He's expired right now, right? So that means it's the current ancestor for him is false, but we are alive right now, so we are the, our current ancestor is true. Okay, so the alive snapshots have got the is current ancestor as true, and the, you know, the uh, expired snapshot have got the is current snapshot as false, current ancestor as false. Okay, I think this video has already got extended. Maybe I'll also break up this video into two parts. Okay, let's see what happens. Now snapshot ID, what is it? The snapshots metadata table is essential for tracking the dataset versions and histories. So the history metadata table basically consists of the evolution of the table, right? Now the snapshot is the evolution of the dataset, data files basically. Okay, I've just run this file. What is there? So this was run when the first insertion has taken place. Okay, we had again the committed that we have got a particular, you know, a particular timestamp for it. We have got a particular snapshot ID for it. Again, the parent ID is null, as we can see, and the operation was append, because we are appending data. Inserting data is again one kind of appending, right? We are not updating anything. And then the manifest list associated with it. So the data file is obviously associated with the manifest list, correct? So that's what is present over here. Okay, now if you look at the summary, we have seen that in the last video when we understood the manifest list basically, right? So in this particular manifest list, what is happening? We had added its particular basically a struct type data set, struct type data, right? Added record is 3. We had inserted 3 values. Now there are two things: positional deletes and equality deletes. Okay, maybe I'll explain you in some other video. So the positional deletes, just understand this or remember this, that positional deletes and equality deletes are actually tracked through different methods. Okay, and that's why the count is tracked differently. We have not deleted anything from the table, so its count is 0. Okay, now change partition count is 2. So changed partition count basically means how many partitions were changed, right? And then the total file size. The total file size is 3066. What does 3066 mean? 3066 means the total bytes of that particular manifest list, right? Of that, or not, I wouldn't say the manifest list, the total bytes of that particular snapshot file. Okay, then in that particular snapshot we have 3 records. We had added 3 data files for it. Okay, so this is with respect to the entire snapshot, right? Then we have the delete files. Have we deleted anything? Whenever you delete something, you create a new delete file. Have you deleted? No, right? Total data files, it's 3. Suppose one data file had got deleted, then we would have only one data file, right? And then suppose I mean to say that we have 3 data files. We deleted 2 of them. We have deleted 2 records which had 2 data files. Then what would have happened? The final total data files would have been 1, right? And then there's the Spark app ID, basically Spark application through which you are run. So these kind of informations are stored in the snapshot metadata table. Let me just again run this one. See, since I had inserted a new value into the table, what has happened is a new snapshot ID is formed, a new record has been created in the snapshot table even. Correct? Because multiple snapshot, that means multiple snapshot IDs. And this table basically, what does it do? It helps us understand the dataset versions and the histories. The metadata one was helpful in understand the table versions. This one is helpful to understand the dataset versions. Okay, what kind of operations are being formed on the set of data files in that particular manifest list, right? See, when I inserted a new value into the table, a new manifest list got formed. And what has happened? The summary has got changed basically after that insertion. Added record is only one. Did we delete? No, right? Did we change? Obviously we did. Total file size, it has increased. It is 4367 right now. Okay. The total records, it's 4. Have we deleted? No. Added it, that's why it's 0. Added data files is 1. Total data files is 4. Right? And then the added file size, how much files, what is the file size for the newly added record? It's 1031 bytes, right? So that's the kind of information that snapshot metadata gives us. It basically helps to understand the dataset versions and the histories. Okay,